Socks. I'll start the recording again. All right. So we're looking at writing and solving proportions today. Yesterday we were looking at ratios and trying to see if they were proportional, right? We had 3 different ways that we got those. So these aren't in your notes, so let's make sure we're just listening. Yesterday we looked at what it means to be proportional. What 3 ways did we have to check for proportionality? What was the first one that we did? Yeah, write in simplest form, right? Write the 2 ratios in simplest form. Second way was? Find a common multiplier. And the third way? Yeah, use cross products. So those are the 3 ways that we have to check for proportionality. So today we're going to use those 3 skills to solve a proportion for an unknown value. What's an unknown value? How do we typically write an unknown value? Letters. We use variables, right? So we're going to be solving for variables. So what we're going to do is we're going to find a value that makes the proportion true. That's what we're going to look for. We're going to figure out, all right, if we've got a proportion, all we have to do is figure out what that value is of the variable to make that proportion true. Remember, how do we check if a proportion is true? Simplest form, common multipliers or cross products. Okay? So the first thing we want to do is we want to check for a common multiplier. I shared yesterday that is going to be the method that we want to use regularly, right? We want to make sure that our cross products, that our common multiplier is typically the easier of the methods. It's typically easier because there's only one thing you got to do. Then cross products is our secondary method. We aren't going to put them in simplest form because the reality is if you have a variable in a fraction, you can't put it in simplest form because we don't know what the variable is. Right? So what's x over 10 in simplest form? I don't know. Well, what if x was 5? Then it'd be a half. What if x was 7? See how we can't put it in simplest form if there's a variable? So we can't do that. So let's just jump right in. So first we want to check to see if there's a common multiplier or divider. And so when we look at these problems, we want to see, is there a number that we can multiply or divide to get the ratios equal, to get the equal ratios? So here we've got ratio here and a ratio here. We know they're equal. So we have to figure out what is the value of z. I think many of you guys might be able to just kind of look at this one and figure out what it is. Because in your head, you're able to figure out the multiplier or divider. In this one, we're actually going to be using a divider. Because I need to figure out what z is, so I need to figure out, oops, that's a yellow. Why do I have yellow? That's silly. I need to figure out what that is. How do I go from 21 to z? Well, it's the same as going from 36 to 12. Because we know that these are equal ratios, right? So a common multiplier would tell me I could multiply this by some number and get that, right? Well, the other way to think about it is I can divide this number by something to get this. What is that? Divided by 3. Which means if I divide 36 by 3, I also have to divide 21 by 3. And I figure out what it's going to be. So notice, what is it going to be?
7.
Yeah, so I have 7 over 12 is equal to 21 over 36. And I want us to write that out because I want us to practice writing out proportions. Proportions are equal ratios. So the answer to this question would be z equals 7. Notice I put a little slash through my z because if I don't put the slash, sometimes it looks like a 2. Okay? And that's the answer to this problem. We know that it's 7 because 7 over 12 is equivalent to 21 over 36. Okay? Let's do example 2 using a common multiplier. So I need to figure out, all right, is this going to be a divider or a multiplier? So I'm looking over here. This is the thing I don't know. This is the stuff I do. We call this a scale factor. So what am I going to do?
Multiply.
Yeah, what am I going to multiply by?
4.
4. Here, this is what I know. I know that the denominator of this fraction is 4 times the denominator of that fraction. Which means the numerator of that fraction should be what? 4 times the numerator. So to set up my ratio, I have 8 over 10 equals something over 40. That something is 32. So that is now my new proportion. So since 8 times 4 equals 32, n equals 32 is my answer. Not a whole lot of solving going on here, right? Much more of like thinking. I sometimes think of the common multiplier as my thinking method. Now the work that you would show for the common multiplier is this. Cool? So whatever, if I'm dividing, I just put the division. If I'm multiplying, I put the multiplication. That's the work we do. Questions? I want you and your partner to solve these. Solve these proportions. Look for common multipliers. So we shouldn't take too much time on these because, well, we're looking for common multipliers. Sure, already done. Talk to your partner about, figure out what those common multipliers are going to be. Or common dividers, right? Multipliers or dividers. Make sure you're showing that division step or that multiplication step. You show. So make sure you're showing. You have to show the division multiplication. Show work. It's like our show work step would be to do the multiplication. And these ones are easier. We're gonna have ones that are more difficult with fractions and with decimals later on. Well, those aren't gonna be more difficult. Just on your homework, you'll have fractions and decimals. So like we'll talk about why we didn't do cross products here. Think about that as we do number 4 of why you don't need to do cross products and how you can figure out what x is without any work. Give you about 1 more minute or so. Justin, you want to come up and sit with Allie so that way you guys have a partner to check? All right, there's our first one. One of the things I do want you to practice is I want you to practice writing this as a proportion. Okay? A completed proportion should be true, right? Isn't the purpose of figuring out what the variable is? Making a true proportion? So that's why I have these written out. And then the last one. These were all kind of nice, weren't they? No fractions or decimals. On your homework, you'll probably have some that might have fractions or decimals in them, so just be prepared. I'm giving you the basics now. You'll have some more complex ones later. Now you'll notice, number 3 was a common multiplier, but 4 and 5 are both common dividers. Excuse me, because I'm always going towards the variable. You see the direction my arrows went? On these two, the arrows went to the right. Why? Because the variable's on the right. And here the arrow went to the left because the variable's on the left. So we want to make sure that we're going towards the variable, figuring out how do I figure out what that variable is. Questions on these? Yes? No? Yeah? Okay. All right, so if we can't do common multipliers, so if there aren't any common multipliers, we can use cross products. All right? What we do is we set up 2 ratios and use cross products. We set those cross products equal to solve that equation. So the first thing we do is, just like with any equation, we build our wall. Then we're going to draw loops. Those are our cross products loops. Remember, Mr. Baker calls them Jimmy Neutron. I call them cross products because they're cross products. And then you're going to write the equation created by the equal cross products, and then it will be a 1-step equation. So let's do it. So I'm going to use colors here to make it a little bit easier to see. There's going to be 1 step that you're not going to want to do, but I'm going to encourage you to do it. Because later on in the lesson today, you'll see why. So when I build my wall, right? So I'm going to build my wall. Draw my loops. When I draw my loop, I don't want to do this in my head. Yes, you can do 7 times 5 in your head. I get it. But I want you to build a habit. Whenever you do a cross product, I want you to write out the cross product. Look on the next page of the notes. Look at number 5 and number 6. Can you do that cross product in your head? Some of you might be able to, but you want to bet that you're going to make a computational mistake. Because on 5 and 6 on these notes, you're going to have to use the distributive property. So I want you to get in the habit of writing out your cross products like this. Because when you get to multi-step questions, if you don't write this out, you're probably going to distribute incorrectly. Okay? So get in the habit now of writing out what your cross products are. I know that you know what this is. I know you know what that is. But if you're in the habit of writing this out, then you'll see later on when we get more complex problems, you'll still be in the habit of writing it out, and you'll be able to see those steps a little bit more clearly. So now we've got 35 equals 2x. That is a one-step equation. Circle my variable. What do I do to both sides? Divide by 2. 2's cancel. I get 17 and a half equals x. Yeah, sure. X equals 17 and a half. I'm not too concerned. Let's do number 4. I'm going to give you a hint. Number 4, you don't need to use cross products on. Let's do it anyway. Think about why on number 4 we might not have to use cross products. While we do the problem, think about it for a second. Let's do our cross products. All right? We build our wall. I forgot to build my wall first. Sorry about that. 5 times x is 5 times x. 2.5 times 22 is 2.5 times 22. And if you want to use your calculators, if you want to use your iPad calculators on your homework today, that's fine. It just makes multiplication go faster. You still have to write out all the work. But remember, multiplication, calculators help you just go a little faster. 5 times x is? 5. Good. 2.5 times 22. 55. The way you do that is you get 2 times 22 is 44, and then half of 22 is 11. So 44 plus 11 is 55. Circle that variable. What do I do to both sides? Divide by 5. X equals 11. So I'm going to go back to my question for you. Did we have to... Why didn't we have to use cross products on this one? How is 11 related to 22? It's half of it. How is 2.5 related to 5? Guys, remember yesterday how I told you that proportions can be written in different ways? We can think about proportions in different ways too. So on these problems, we thought about the proportion left to right, didn't we? What's my common multiplier moving left to right? I could have also simplified my fractions. Thinking about how is 2.5 related to 5? Well, it's half of it. So if this relationship is a half, what should this relationship be? A half. That's what so earlier I said the thinking method, that's what I call the thinking method. If you can start to look at ratios as relationships, then you'll be able to do these really fast. So the work for that one would be 2.5 is half of 5, so 11 is half of 22. That would be the work. That's what you grab. So if you can see that, it makes it so you don't have to do cross products. Now, did I teach you that method? Did we write notes on that? No, because I'm asking you to think about that. All right? When did you see that? Good. So I know you're always looking for shortcuts. That would be the shortcut, right? It's faster, isn't it? Remember, proportions are a comparison of ratios, right? Saying that these two ratios are equal. So if the value of this ratio is a half, then the value of this ratio should also be a half. Okay? So I challenge you, do number 1 without any work. Do number 1 without common multipliers on the next lines. Do number 1 without multipliers and without the cross products. Talk about your partner. Talk about it with your partner. Tell your partner what you can do and why. Ready, set, go. So what do we see? What do we see?
It's half.
What's the relationship in the ratios? What's the relationship between the ratios? Yep.
8 is half of 16, so 3 is half of 6.
8 is half of 16, so K must be half of 6. What's half of 6? 3. So that's the work that I would have. That's the work. 8 is half of 16, so K is half of 6. And that's not going to work on 2 and 3, just letting you know. But it's something to look for. If you can see that relationship, it'll make these problems go a lot easier. It'll make these problems go a lot easier. In fact, some of you guys on these ones that are a little more tricky might see this relationship too. Okay, just keep that in mind. I want you and your partners to do 2 and 3. Do 2 and 3 using cross products. Please use cross products on 2 and 3 because it's a little bit easier to use cross products. Talk about it, the steps that you're doing. Go through them together. Not independently, together. I'll give you about 3-4 minutes to do this. What did you do wrong? Well, you're talking with Roman. Okay. Oh, let's talk about this with Roman as we're going through this. This is why I don't want you look ahead, because I want you talking through it. Guys, please show that intermediate step. After you do your cross product, please show that multiplication. I promise you, it will serve you well in the future, in the long run. So we should be doing, we aren't going to do this here. Just wanted to say what the multiplication is. So like we did up here. I don't know why your circles aren't there. Draw your loops. So 7 times 5. Like we did here, 7 times 5. 2 times 6. That's what I want to see on here. So when you draw your loop, write your multiplication. 7 times 27. I'll use calculator for that one. 7 times 27. I'd use calculator for that one. 7 times 27. I'd use calculator for that one.
Figure out that multiplication.
Yeah, that was a great method in elimination. We want to move past that. We graduate from that. So that was a really cool thing to think about in elementary school. But now we want to, since we're working with numbers, for speed's sake, we want to use our calculator.
You have to take this answer, this over here.
I'll put the answer number 2 up there.
8.
So like I said, you can use your calculator on these, okay? 189 divided by 5.4, I wouldn't do that. I'll use my calculator for that one. Well, save time, because I want to move on to number 3. I want to be done with number 3 here in the next, I don't know, minute. So we want to use our calculator. That was a funny sound. That was funny. All right. How we doing on number 3? Now, number 3 is one of those that we could use cross products, but you can also see how 20 is related to 8. It's 2.5. Or you can simplify 20 over 8. 20 over 8 would simplify to 5 over 2. So that would be kind of how we could figure out 15 over. So we just divide it by 5. Just different ways to think about it. If you can think about it that way, cool. I don't think about it that way. Now, we're going to do number 4 together. We'll do number 5 together, and you guys will do 6 independently. Number 4, why is this one a little bit trickier? Yeah, there's going to be 4x. So it means that there's going to be multiple things that we have to look at. Okay? So when we solve this proportion, what we want to do is we build our wall, we do the same exact steps. Here's where it's imperative that you do that multiplication step like I mentioned. 8 times 5. 4x times 2. What's 4x times 2? What is it? 8x equals 40. This is why showing this is going to be really, really helpful. You guys can solve that one in a moment. Let's do number 5. Here's where it comes into really, really importance. Okay? So we've got 4 times 11. And I have to be careful here. I'm going to show you what it's not. It's not this. Why? So I'm telling you this is not what it is. Why?
We don't know the values of y.
There's
Isaac?
like terms.
What?
There's like terms.
No.
Do you have to use the distributive property?
Yeah, what does this say?
8 times y plus 2.
8 times y, then add 2 to it. But what am I actually multiplying together?
82.
8 and y and 8 and 2. I'm multiplying 8 times everything down here. What if y was 10? 10 plus 2 is 12. 12 times 8 is a big number. But 8 times 10 is 80, plus 2 is 82. We have to use parentheses. Here's a big one for us. Make this note. Use, I never know how to spell this word. It's an E. I don't even know. I'm a math teacher. Use parentheses. So here, we have to use the distributive property, right? Distribute. So when I do this multiplication,
It's only 8.
I've got 44 on the left equals, do my distributive property, 8 times y, not plus 2, but plus 16. Why? Because 8 times y, 8 times positive 2. Just remember that step, what the distributive property is? All right, finish number 4 and number 5, and then I want you and your partner to try to tackle number 6. Okay? I might have a student go up and do number 6 on the board. Might. So do you see how this is a 2-step equation now? So make sure you do the inverse operations right. Elsa. So what should happen first? Remember when I told you to use your calculators? Use your calculator. Make it go faster. Remember, a calculator is just to make multiplication and division go faster. It's just to make it go faster. It's not to replace the work. It's just to make this step go faster. Okay? How we doing? Finishing up number 5. Keep in mind we use inverse order of operations, right? So on number 5, we have to use the inverse order of operations. So we circle the variable and its coefficient. And we show our steps, subtract 16 from both sides, divide both sides by 8. This is where the calculator just makes things go faster, okay? You're still required to show all that work, still required to do the steps, but you don't have to do this division in your head. You don't have to do this multiplication in your head. Got anybody who wants to do number 9 or number 6 up on the board? Who wouldn't mind being filmed?
I would.
Cool. All right, let's see it. You can go up to the sideboard and do it. I'm scared. Olivia's gonna do great.
I don't care, so.
Hold it like this. You got this. Just gonna hold it. All right. So she's gonna be doing it over here. You guys are gonna be checking it. Okay. As she's doing it, you guys are gonna be checking it.
Usually she'll work, so this is
Do that 3 times 15 on the other side. Are you watching her? Checking to see what mistakes she's making. It's a guy. Turn around.
Am I making any mistakes?
You guys are checking to see if she's making any mistakes. Is she making any mistakes yet? She's doing spot on. Can you put equal sign? Awesome. You should be following along with her. Say ta-da.
Ta-da!
Nice. We're zooming in. Ready? And whew. Did she make any mistakes? No, spot on. She did the multiplication here. Wrote it as a distributive property, right? Distributed the 9, 9z minus 1. One thing that I would add, because I'm a math teacher, what does this kind of look like? What's it kind of look like? 2 minus 1. Don't make that mistake. It might be a good idea when you're doing math to put a little line through the z's, okay? Just keep that in mind. It might be helpful. That way you don't make the silly math mistakes, right? 45, inverse operations, subtract 9. Excuse me, you're subtracting 9 here, so we add 9 to both sides. Divide both sides by 9, and we get positive 6. Spot on. Questions?